Okay, hello. So today's task is, let me fix it a little bit like this. So today's task, Pacific Atlantic flow. Solved it in the past, like 1 year ago, around 1 year ago. Let me read that one and I'll start solving it. Okay, so what I can think about this problem. So for sure, we already have a cell in both Pacific and Atlantic Oceans, and like Atlantic Ocean, like the cell 5 is already connected to Pacific and Atlantic Ocean, and cell 5 here also um, connected. So for every cell, I should decide if mhm. So should return the cells that can from which water can flow to both Pacific and Atlantic Ocean. What idea I have right now? So I can start with I can add the output like Pacific and Atlantic Ocean, like five this two cells, and then And I can add like this one, like this is Atlantic Ocean. If I do mm, BFS for the expansion for the Atlantic Ocean cells, I'll expand it to 4. No, not expand it to 4. I'll expand it to 1. It's already there. So I take the cell and check if it's visited, and if I check all the neighbors if I can expand, and add the neighbors if I can expand. Then I do that until I reach certain point where I cannot expand. And let's say I mark those cells as reachable from the Atlantic Ocean. And then I do the same for the Pacific Ocean. So I add all the cells um, to the reachable from the Pacific Ocean, and then I'll gradually try to expand it to the highest, like expand it until I cannot longer expand it, and then I'll have this. I'll have this. I'll go through the heights, and for every cell that is both reachable from the Pacific and Atlantic Ocean, I'll add them to the output. So I wonder how if I can solve this problem with like constant like space. Probably no, because I'm gonna use the queue for the BFS or like stack for the DFS. Also, I can start union find and like expand it until I can, and then start union find for the Pacific Ocean, all the cells on the top and right, left side of this rectangle, and expand you do union find for like for every cell, adjacent cells that have higher heights. Yeah, but it might be a little bit more difficult because I need to track those pairs, yeah. This is very similar to this problem, percolation scientific, but it was like up and down, where they expanded, connected to the top, okay. So I do the expansion. percolates is full. Okay, so just checking if the higher cell is full. Can I do better here? So if I do heats and then Atlantic Ocean, if I put minus for the all cells reachable from the Atlantic Ocean, so I put minus here for the 5, minus for the 4, 1, 5, 4, 2, 1, 5. I like put minus 4, minus 5, minus 1, change the sign. And then for all these nodes that we can flow, I add the 4, so gonna be minus 4, etc., etc. So I added all of those, and then I go to from the from the Pacific Ocean. And I check where I can expand, and let's say I can expand like here, here, here. Whatever. Okay, so I'll do this. Let's say have int speed minute boolean reachable at 1. Atlantic cells. I would say int rows equals heights, length int calls equal heights zero length, and I'll do that equals new boolean rows calls. So I'll do public private void BFS, and then visited. This is gonna be boolean, and then gonna have int heights and then I'll have the Q and Q. So what I'll do while Q is empty, well, it's not empty, I'll do the Q dot poll, then int position, like so, Q dot poll, so there's gonna be coordinates of the cell, and I'll do, let's say, directions. So it's gonna be neighboring cells and directions. One. So I'm gonna go 4 in D equals 0, 4, let's say, deer and deers. If say next I equal cell 0 plus deer 0, next j equals cell dot 1 plus deers dot 1, and then I'm gonna check if next I greater than, let's say I'm gonna save it again here, if next I greater than greater or equal rows, or let's say next I less than 0, or next I greater than rows, or next j less than 0, or next j is greater than or equal calls. Then I'm gonna continue. Then continue. And then I'm gonna have this visited next if or let's say visited next I next j or visited. Okay, then I'm gonna continue. Else visited next I next j equals true, and then I'm gonna have q dot offer new int next I next j. So that's it, and then I'm gonna go and do the following. So it's gonna be gonna update the visited array, and then I'm gonna BFS, gonna and also I need to check if heights next I next j is greater or equal, I assume. Description. So the water can flow less or equal to the current cell's height. Okay, so it should be if it's next less than height current cell, and then cell 1, then I'm gonna just also continue. So if this one or this, that's it. So Atlantic cells, so I'm gonna do this for int I, I so I need to add all the cells to the right and all the cells on the bottom. So I go int I equal I less than rows I plus plus, need to add Atlantic, and then I have q int at Atlantic q equals new linked list, and then Atlantic cell I, and then column calls -1 equal true, and then I do Atlantic q that offer new int, and then here gonna be I, and then calls -1, and then and the same I'm gonna have Pacific cells, Pacific cells rows Pacific U, and then Pacific gonna be the left side of the rectangular and the top side. So the Pacific cells I0 equals true, and then Pacific U dot offer new I dot 0, and then now it's gonna be top and bottom. So I'm gonna do for int j equals 0, j then goes j plus plus, and then Atlantic cells. So Atlantic cell is on the bottom. So Atlantic cell gonna be rows -1, and then yod equals true, and then Atlantic q that offer a new int rows -1, and then yod, and then I'll do the same Pacific cells 0, and then yod goes through, and then Pacific q that offer new int rows, so 0 and then yod. And then what I'm gonna do, I'm gonna run BFS twice. So for the first one, I'm gonna run BFS for the Atlantic Q, then height, then Atlantic cells, and then the second one gonna be for the Pacific Q, height, and then Pacific cells, and then for int I equals 0, I less than rows I plus plus, and then for int j equals 0, j then equals j plus plus, and then I'm gonna check so I'm gonna save the result list of integers. So list integer result equal new array list. So result that add if, let's say, if Atlantic cells yacht and Pacific cells yacht. Then I'm gonna add result.add here new array list, and then here I'm gonna add add yacht, and that's gonna be it. And I'm gonna return the result. Yeah, a little bit out of time. Return result. So let's check if it's gonna work. Bed operator for the binary sub plus gears plus dir. Okay. Local variables reference set from in class can be final file. Add. Whatever. Let's say list coordinate equals new array list. Coordinate add coordinate add yacht, and then coordinates. I don't know why it's integer list. Okay. Okay, that's it. So I was solving that within like 37 minutes. I guess I spent a lot of time on the on explanation and like figuring out like what should I use and like different approaches here and there. So the high level overview for this solution, I'm gonna run two BFSs. I ran two BFSs, and for the preset up the queue for the BFS at like Atlantic cells, cells neighboring to Atlantic Ocean and Pacific cells as already visited, and like add them to the queue, and do the BFS, two BFSs, and then for the cells that have a connection to both Atlantic and Pacific oceans. I'm gonna have this visited for the Atlantic BFS cells, like Boolean array, like matrix in Atlantic cells, and for the Pacific cells visited cell in post cells. So I'm gonna go through their all cells and check if the cell is both connected to the Pacific and Atlantic Ocean. I'm gonna add the coordinates of the cell to the result. So the time complexity for this one, so this is standard BFS. I go like rows by calls, and I visit like once. So the space complexity rows by calls, time complexity gonna be also rows by calls. Every BFS will take rows by calls, and then finally I'm gonna row by calls check the coordinates, like check the cells and populate the result. Like lists of integer. So that's it. That's a sketch. Yeah, that's it. So the status is pass.